When installing multiple 1600 watt, 120 volts hairdryers, a standard 180 volt amps per receptacle calculation is not appropriate. Since hairdryers are non-continuous loads, we can use a demand factor to more accurately size the circuits. To determine the appropriate circuit sizing, follow these steps. Firstly, estimate the demand factor. Determine the typical number of hairdryers likely to be in use during peak hours, perhaps 30%. Then apply this demand factor to the total load. For example, a 30% demand factor applied to 98 hairdryers would be calculated as 0.3 times 98 times 1600 watts, equaling 459,200 watts. Secondly, calculate the required circuit ampacity. Convert the total demand to volt amps by dividing the total wattage by the voltage. In this case, 459,200 watts divided by 120 volts equals 3,826.67 volt amps. Determine the circuit ampacity by dividing the volt amps by the voltage. So 3,826.67 volt amps divided by 120 volts equals 31.89 amps. Thirdly, select an appropriate circuit breaker. Choose a circuit breaker rated for the next standard size above the calculated amperage. In this example, a 40 amp circuit breaker would be suitable. Based on this analysis, wiring multiple 1600 watt hairdryers on a single circuit is possible without exceeding the circuit's capacity, but consider these recommendations. Use 12 American wire gauge wire for the circuit to ensure adequate current carrying capacity. Provide at least one receptacle per hairdryer to prevent overloading and consider additional receptacles for convenience and future expansion. Install arc fault circuit interrupters, RFCs, on the circuit to enhance safety. Using a demand factor bases circuit sizing on the actual expected load, not the maximum potential load. A 40 amp circuit breaker provides a safety margin while still allowing for simultaneous use of multiple hairdryers.